Howdy and good day, fellers. It's good to be back with you teaching math, even if it is in front of an empty classroom. It's probably better you can't see my face anyway because I am rocking a wicked beard, one of the benefits of isolation / quarantine. But today in Algebra PO24, we're going to kind of go back to our work with slope-intercept form and standard form. And what you did in CO23 was you were given an equation in standard form and asked to write it in slope-intercept form. Okay. Today, you'll be given an equation in slope-intercept form and asked to put it back into standard form. So it's kind of the reverse, the opposite of what we're working with in CO23. So slope-intercept form, just as a reminder, is y equals mx plus b. And the advantage to an equation in slope-intercept form is that it very distinctly identifies the slope of an equation or a graph and the y-intercept of the equation or a graph, right? That slope is that m variable there, the y-intercept is the b variable there. So when it comes to graphing an equation, which we're going to be doing in PO25, slope-intercept form is a very, very useful and handy equation to have. Standard form is ax plus by equals c. And we use a capital B there because there is really no direct relationship between the lowercase b in slope-intercept form and the capital B in standard form. A, B, and C just represent coefficients, okay? Or in the case of C, a constant. So if you notice, the relationship between these two equations, we've talked about this before. Standard form has our x and y terms on the same side, whereas slope-intercept form has y by itself, okay? And when we converted from standard form to slope-intercept form, if you remember, our steps were first remove that x term over to the other side using opposite operations, and then we divided everything by the coefficient to y. Just as a brief review of this, I'll just put an equation up over here in standard form. Let's say we got 4x plus 3y equals 18, okay? That's an equation written in standard form. And to convert this into slope-intercept form, what we did was we first moved that x term over, right, by subtracting, in this case, opposite operations. To cancel that out, we're left with 3y. And remember that 18 and the negative 4x can't be combined because they're not like terms. So what we did, knowing that we were going into slope-intercept form, we would put that x term first, negative 4x, and then a constant written after that. So we have 3y equals negative 4x plus 18. Hopefully this rings a bell. And then to get y by itself, we would divide everything by 3. This is where we got to kind of draw this cute little heart-looking thing here, right? Right? Divide this by 3 too, okay? And basically, we'd be left with y by itself equals, we didn't care that negative 4 divided by 3 didn't work out evenly because it's slope, it's a fraction anyway. So negative 4/3 x and then 18 divided by 3 is positive 6, and that would be our answer. We could say the slope of this line is negative 4/3, and it crosses the y-axis at 0.6. So that was kind of the heart and soul of CO23. And so today in PO24, we're talking about going back, okay? Taking an equation that's in slope-intercept form and go back to standard form. And so since we're going back to standard form, our steps are going to basically be the opposite of what we did to get to slope-intercept form. So I'm going to erase this over here so I have a little more space to write. Yeah, that was kind of an example there. But our first steps to convert from slope-intercept form to standard form is we are going to multiply each term by the denominator of our slope, or if our y-intercept is also a fraction, the least common denominators of the two we have. Okay, so since we're dealing with slope-intercept form, if our slope is a fraction, then we're going to be multiplying each term by the denominator of that fraction to essentially cancel it out, to get rid of that fraction there. Okay, if we have more than one fraction, such as in this third example that we'll do together shortly here, if we have more than one fraction, to undo both of those, to get rid of both fractions, we're going to be multiplying by the LCD, the least common denominator of the fractions we have. Okay, so once we do that, step 2, and I never know why I give 2 lines for step 2. It's not really all that long of a step, but basically, using opposite operations, we're going to move the x, I guess this is why I have 2 lines for this one, move x term to the other side. Right? You'll be giving an equation in slope-intercept form where y is by itself. So our first step is to, instead of divide everything, right, we're going to be multiplying everything by the denominator of that fraction, or the LCD of the multiple fractions we have. That's going to get rid of them. And then we're going to move that x term back over to be with the y term to get into standard form. Okay? All right, let us practice. So the first one here, it says write the equation in standard form, show your work. Y equals 4x plus 7. In the spirit of Christmas, the first one that we're going to do together actually doesn't have any fractions at all, right? Happy day. We don't have to multiply by anything because there's no denominators to work with here. So we can skip step 1 and actually move directly to step 2, which is move that x term over to the other side, right? Right now it's in slope-intercept form, y equals mx plus b. We want to move that x term over with the y to then put it into standard form. So we do that using opposite operations, subtract 4x from both sides, because 4x minus 4x equals 0. That leaves us with just that constant there, positive 7. And on the left side, to be in standard form, ax plus by, the x term is written first. So instead of, maybe you want to write y minus 4x. No, reverse it. Negative 4x and then plus y. And that y is positive because it was, positive up here in slope-intercept form. And so now we have the equation written in standard form. Okay, negative 4x plus y equals 7. The next one, y equals 3/2 x minus 5. In this case, our slope is a fraction. So to undo that, we're going to be multiplying everything by positive 2. So I'm just going to write times 2, and yes, even that y on the left side gets multiplied by 2 as well. Okay, and on the left side, y times 2 is just 2y. I'm going to focus on that 3/2 x times 2. Why does multiplying by the denominator cancel it out? Why is this an important step? Well, let's just kind of go over here and let's look at what happens when you multiply 3/2 times 2 or 3/2 times 2 over 1. Okay, we know that we multiply fractions by going straight across. So 3 times 2 is 6. 2 times 1 is 2. All right, sorry for that pause there, but when the wife calls, you answer. So there we go. So we have 3/2 times 2 over 1. 3 times 2 is 6. 2 times 1 is 2. And if you notice, that fraction 6/2, well, that's equal to 3, isn't it? 3 over 1 or 3 wholes, which is the numerator of the fraction that we had, that 3/2. You think all the way back to when you started multiplying fractions, you probably learned that you can simplify diagonally. So by multiplying by 2, they cancel out, and then we're left with 3 over 1, which is just 3. So that's the math behind it. And so what we end up with is 2y equals 3x, and negative 5 times 2 is is a negative 10. 2y equals 3x minus 10. What that first step does is it eliminates fractions because there are no fractions allowed in standard form. Okay? No fractions allowed in standard form. Integers only. And so now our second and final step is to move that 3x over to be with the y. And so using opposite operations, subtract 3x from both sides. On the right, they cancel out. We're left with that negative 10. Don't forget about that sign. Now on the left, we've got our negative 3x, positive 2y. It looks like negative 3x plus 2y, and that equals negative 10. Okay. The third one here are multiple fractions. So in this case, we're going to get rid of both fractions at once. And so we're going to look at the denominators of each of them and multiply everything by the LCD, the least common denominator, which happens to be 10, right? It's essentially the least common multiple of 5 and 10. What's the smallest number that both 5 and 10 can go into? That would be 10. So we're going to multiply everything by 10. You got to be a little more careful here when you've got these multiple fractions. Everything kind of stays the same with that y times 10. That is going to be 10y. But with negative 4/5 times 10, our denominators don't just cancel out here. Negative 4/5 times 10 over 1, multiply straight across, we get negative 40 over 5, and negative 40 divided by 5 equals negative 8. So it's really nifty when we've only got one fraction to work with, and the denominators just cancel out like we had in that second example. Okay, we just left with that numerator 3. In this case, we're multiplying by 10, so negative 40/5 equals negative 8. But our second one, negative 3/10 times 10, since we are just multiplying by 10 over 1, here they do cancel out, and we're left with negative 3. Okay? So 10y equals negative 8x minus 3. Move those x's over. Since they're negative, this time we're going to be adding 8x to both sides. On the right, they cancel out. We're left with negative 3 as our constant, and we have positive 8x and positive 10y, or 8x plus 10y equals negative 3. That is our equation in standard form. Okay. The next four here are just a kind of review of PO23, but I feel like we've done enough of these where we don't need to go over them now. So let's scroll on down here to page 2, where we have some more practice writing the equation into standard form. You will have 5 of these in a Google quiz that will be your homework for tomorrow. You must get 100% on the Google quiz. So after you submit your score, you'll go back, you'll take a look. If it's not 100%, then edit your response. It'll show you which questions you got incorrect, fix them, and continually attempt it until you get to 100%. So the first row, you have no fractions to work with here. Happy day, okay? It's fun. The second row, you've got one fraction, just that slope. In the third row, you've got multiple fractions. So I think I know what you're going to want me to do up here with you now. It's going to be one from the third row, probably the last one, because why not? Okay, so let's look at y equals negative 3/8 x plus 9/5 here. I've got multiple fractions. So my first step, multiplying everything by the least common denominator of 8 and 5. What's the least common multiple of 8 and 5? The smallest number that both 8 and 5 can go into. Well, that's going to be 40. Okay, so I'm multiplying everything by 40. Right, that's my first step. And where that 40 came from was it's the LCD of 8 and 5. Okay, because I want to get rid of all of these fractions here. No fractions allowed in standard form. So my first multiplication, y times 40, that's easy. It's just 40y here. But negative 3/8 times 40. Let's do that down here. Negative 3/8 times 40 over 1. Okay. You can simplify here if you want to, or simplify at the end. Doesn't really make a difference. But 3 times 40 is negative 120. 8 times 1 is 8. What does negative 120 divided by 8 equal? Negative 15. So we got negative 15x. Then we've got 9/5 times 40. Whoops. (40 over 1). 9 times 40 is 360. 5 times 1 is 5. What's 360 divided by 5? 72. And so we have 40y equals negative 15x plus 72. Okay. If you wanted to simplify first, you could recognize that 40 divided by 8 equals 5. And you're just left with negative 3 times 5, which is negative 15, the answer we eventually got. If you wanted to simplify here, 40 and 5, 40 divided by 5 is 8. 9 times 8 equals 72, which is the eventual answer that we got there. So whether you simplify first or at the end, it doesn't make a difference. You will get the same answer. But by multiplying by 40, we've eliminated all of the fractions. Our only step now is to move those x's to be with the y's on the left side. I do that using opposite operations. Add 15x to both sides. That gives me positive 15x. My 40y is also positive, so 15x plus 40y equals a positive 72, which is what the constant is on that right side. Okay, so PO24, we are going from slope-intercept to standard, and you've got your 2 steps to do that. So of the 8 remaining on this, this top part of the page, 5 of them will be on your Google quiz. So do the work here, then go to Google quiz and take it. And if you don't get 100%, then please do redo until you get 100%. What's this section down here? I don't know what this is. Use the information to write the equation of the line in standard form. Show your work. Let's not quite do this yet. Yeah, no. Let's just focus on that Mr. Happy Pencil section up the top there, converting from slope intercept to standard, and the Google quiz there. By the time you watch this, it'll be Wednesday, which means your Khan Academy is due tomorrow on Thursday. So if you finish this quiz in class, then please work on your Khan Academy. You got your math packet yesterday as well. Oh, geometry folk, your math packet is up at my desk. Please do pick one up before you leave today. That is due Friday the 18th as well. I got an email request last night for a video on kind of how to go through the math packet. I will make that and post it as quickly as I can. It's not going to be as in-depth as the other ones that we've done together. But at least have something to get you started. And of course, my email inbox is open for questions, comments, concerns, complaints, comments, congratulations, or criticisms. So with that, that is how you math. Do not forget to like and subscribe, and I look forward to seeing the Google quiz scores coming in. Have a great day.